We're talking about section 6.3 here. Conditions of parallelograms. Again, what's the root word in the word parallelograms? Parallel. What means parallel? What's a parallelogram really mean?
Two sides of the same.
Opposite sides are parallel. Okay, opposite sides are parallel. Yesterday we talked about 4 properties of parallelograms. Who remembers what any of the 4 properties of parallelograms are? And not just the opposite sides are parallel. That's part of the definition. Who remembers one of the properties from yesterday? Opposite angles are congruent. That's one. Okay, in a parallelogram, opposite angles are congruent. That is true. There's one property. There's 3 more.
Opposite angles are the same.
Opposite sides are, well, that's, yes, we already said the opposite sides are parallel. But opposite sides are also congruent. There's property number 2. So opposite angles are congruent. Opposite sides are congruent. 2 more properties. Who remembers the other 2 properties? Something deals with the diagonals. The diagonals bisect each other. There's the 3rd one. And the 4th one, something about consecutive angles.
Opposite angles are parallel.
Already knew that. Consecutive angles are what? In a parallelogram, think about it here. Let's say I draw a parallelogram. What do you know about these 2 angles right here?
They're yeah, same side.
Same side interior angles, so they are supplementary.
I was right there.
Okay, so yeah, parallelograms, opposite sides are parallel, opposite sides are congruent, opposite angles are congruent, same side interior angles or consecutive angles are supplementary, and the diagonals bisect each other. Those are the properties we talked about yesterday, which leads us into the conditions of parallelograms. So, in the flip side here, if one pair of opposite sides is parallel and congruent, then it's a parallelogram. So we're going to kind of flip this and think in reverse today. If I give you some properties, you got to tell me whether it's a parallelogram or not. So for example, if opposite sides are parallel and congruent, it's going to be a parallelogram every time. If both pairs of opposite sides are congruent, then it's a parallelogram. So notice here, opposite sides are congruent, it's going to be a parallelogram. If opposite angles are congruent, what do you know? It's a parallelogram here. And the last one, if diagonals bisect each other. What's it mean to bisect? Cut in half, so make them equal to each other. Okay, if they bisect each other, those are also congruent. So those are the 4 properties there, or conditions. And then the last one here, which is what we talked about yesterday as well. If consecutive angles are supplementary, it's also a parallelogram. Okay, so notice here, 115 and 65 is 180. 65 and 115 is 180. It has to be a parallelogram. So again, we're taking what we learned yesterday, flipping the logic around and saying, hey, if these properties are met, it is a parallelogram. So number 1 here, show that each quadrilateral is a parallelogram for the given values. It gives me x equals 9 and y equals 4. What am I going to do with the x equals 9?
Put it for every x.
Plug it in there. So 2 times 9 minus 6 gets me. And take 9 and plug it in over here. 9 plus 3 is? Hey, those are the same. Great. Let's try 4. I take 4 and I plug it in. 4 times 4 is?
16.
I take 4 and I plug it in down here. 4 plus 12 is?
16.
Are opposite sides congruent?
Yes.
Is this a parallelogram?
Yes.
Yeah. Kind of. 2. It says W equals 3 and Z equals 31. Parker, what am I going to do with those 2 values? I'm going to. So I get W equals 3. 4 times 3 minus 2. Parker, what do you get? 10. Then I take 3 and I plug it in down here. Parker, 3 plus 7 is? 10. Awesome. Then I'm going to take 31. I'm going to plug it in. 3 times 31 plus 25. Let's go with Jake O'Connor. 3 times 31 plus 25. What do you got? 118. Great. And then I take 31. I plug it in down at the bottom. 2 times 31, Jake. Are those angles the same?
No.
Well, should they be the same?
No.
No, because they should be
Equal to 180.
equal 180. Are they supplementary?
Yes.
Yes. If they're supplementary, that means these lines are Parallel. Is it a parallelogram?
Yes.
Yes. So again, recognize, we're not always looking for things to be the same. Sometimes we're looking for them to be supplementary. Take a couple seconds, try these two on your own. All right, let's walk through number 3 here. I need to take 9 and I plug it in here. What's 8 times 9? Get me, Spence. Then I take 9 and I plug it in for C. 9 squared minus 9 gives me what, Spence? Awesome. Take 11 and I plug it in. 10 times 11 minus 2. Blake, what'd you get?
108.
Then I take 11 and I plug it in for D. 9 times 11 plus 9, Blake. Is it a parallelogram? Yeah, it's a parallelogram. Opposite angles are congruent. It's a parallelogram. Consecutive angles are supplementary. It's a parallelogram. Okay. 4. Becca, walk me through number 4 here. I take 4.3 and I plug it in. What do you get for HI there? 8.6. Then I take 4.3 and I plug it in down here. What's IG going to be, Becca? Then I take 13 and I plug it in. What's EI going to be, Becca? Then I take 4.3 and I plug it in down here. What's IF going to be, Becca? Is this a parallelogram? No. Why not, Becca? Do the diagonals bisect each other? No, the one bisects, the other one is not bisected, so it's not a parallelogram. Nice job. So don't just think, oh, it looks like a parallelogram, because it might not be. Okay, next we're going to talk about here. Now pay attention, because we're going to look at some parallelograms and determine whether it is an actual parallelogram or not. So you can show that a quadrilateral is a parallelogram by using any of the conditions listed below. Okay, so these 6 conditions can be used to show that it's a parallelogram. For example, if both pairs of opposite sides are parallel, well, that's the definition of a parallelogram. If you see that, it's always a parallelogram. It's gonna work. If one pair of opposite sides is parallel and congruent, then it's a parallelogram. If both pairs of opposite sides are congruent, it's a parallelogram. If both pairs of opposite angles are congruent, it's a parallelogram. The diagonals bisect each other. And if one angle is supplementary to both its consecutive angles. For example, down here, if you look right here, parallelogram EFGH, would that be a parallelogram?
Yep.
Yes, and because of which condition up there?
Congruent sides.
Be both pairs of sides are congruent. That's that one right there, right? So because both sides are congruent, it's a parallelogram. JKLM, is that a parallelogram?
No.
No. Because I don't know about angles J and L. Okay? It gives me one pair of opposite or one pair of angles. I need 2 pairs of angles. Okay? So that would be a no. So we're going to look at some parallelograms and determine yes or no, is it a parallelogram?
Wait,
Sorry, what's up?
where it says one pair of opposite sides parallel, concurrent, what is that? That's like
What?
Like one side is parallel to the like
Which one are you talking about? 1, 2, which condition?
2. If
Okay.
K and L are parallel, then
If one pair of opposite sides is parallel and congruent, that's like saying this. So if I have a parallelogram here, if I'm saying this is parallel and congruent, then it's a parallelogram. Great question. Does everybody see what he just asked? Yes, what that one meant? It means that the same sides are parallel and congruent. Then we know it's a parallelogram. Great question. Okay. So again, we talked about this earlier. Quadrilateral is a parallelogram if the angles are consecutive. Okay, so let's look at number 5 here. Determine whether each quadrilateral must be a parallelogram. Read. Great question on number 5. Is that a parallelogram? Yes, it is. That would meet that condition. The sides are parallel and congruent. That is a parallelogram. 6. Would 6 be a parallelogram? Yes or no? Colton Wilkie. It is. Why? Yeah, the diagonals bisect each other. So that means it is a parallelogram. Nice job. Now, number 7. Yes or no? What are you thinking here, Claire? Is 7... Now, again, we can't just say it looks like a parallelogram. Would this always be true for a parallelogram? Claire, yes or no? No, I agree with you, Claire. Why? Is there any condition that says parallel and the other sides are congruent? Is any of those conditions say that? No. Because what happens here is we sometimes get shapes that look like this, where these sides are parallel and these sides are congruent. What shape is that? That's a trapezoid. Well, is a trapezoid a parallelogram? Now, would a trapezoid have basically the same marks as number 7 here? Yeah, so, and again, that's not always a parallelogram. Okay, so no, 7. Does everybody see the difference between 5 and 7?
Yeah.
Because a lot of times people are like, well, that's the same thing. No, different sides are congruent there, so recognize the difference in 5 and 7. 8, would 8 be parallelogram, yes or no?
No. Yeah.
Yes, it is. Opposite sides are congruent, or opposite angles are congruent, I mean, so that is a parallelogram. So notice we're recognizing those conditions there. Take a couple seconds, try these 3 on your own. Katie Ekstrom, number 9. What are you thinking, yes or no? It is no. Why not, Katie? They don't bisect each other. To bisect, these two have to be the same, right? And those are not the same. Same here. Okay? Because these angles, or these sides and those sides are the same does not mean it's a parallelogram. So this is not true. Number 10. Kind of a tough one. What are you thinking here? Simeon. Number 10. What are you thinking? Number 10? Yes or no?
Yes.
It is a parallelogram, actually. Now, pay attention here, and I'll show you why. Okay? Because this goes back to what we did in chapter 4. All right? Pay attention here. Does everybody see these two sides are parallel?
Yeah.
Okay? Because those two sides are parallel, I know angles 1 and angle 2 are going to be congruent because of alternate interior angles. So they're congruent. What do I know about angles 3 and angles 4? They're going to be congruent because they're vertical angles.
So what's the 3 and the 4 and 1 and 2 there?
They're just to show the angles. So what happens here is, pay attention. What do I end up finding out about this triangle right here and this triangle right here? They're congruent. And because they're congruent, that means these two sides are congruent because of CPCTC. It also means that these sides are congruent because of CPCTC.
Also, like, think of it because...
What?
How do you remember that?
Everything we've done. Tying it all together right there. Which means now, this...
CPCTPC.
Oh, corresponding parts, congruent triangles are congruent. Awesome.
You know, like, couldn't it also be because, like, 1 and 2 you add 1, and then 3 and 4 you add 1 to get that other one?
There's a lot of different ways. But that's one of the best ways to do it, yeah. And then last one, number 11. Shh, focus back in here. 11, is it a parallelogram? Yes or no? Trent Bannister?
Nah, dang it.
It's not a parallelogram.
Thought it was.
Okay, now here's the thing. A lot of you look at this and are like, well, yeah, it's a square. It's got to be a parallelogram. But the question is it always going to be a parallelogram?
No.
Let's pick x is 10. If x is 10, so let's say this angle's 10 and this angle's 10. Are my angles supplementary now?
No.
Don't you remember consecutive angles have to be supplementary? What x value would be true here? There's one x value in this problem that it'd be true for a parallelogram. Yeah, if x was 90, this would be a parallelogram. But because we don't know what x is, it's not necessarily a parallelogram. Okay, so recognize that. Last thing we're going to talk about today is we can do parallelograms in a coordinate plane. So I want to plot the coordinates of quadrilateral EFGH. E is at coordinate 1, 1. F is at coordinate 4, 5. G is at coordinate 6, 6. And H is at coordinate 3, 2. And I'm going to connect the dots here. And the question is, I want to determine if this is a parallelogram or not. Well, tell me some things we know about parallelograms.
The slopes have to be the same.
Opposite sides are parallel, right? So can I just find the slopes of this?
Yeah.
Yeah. Well, what's the slope from F to G?
1, 1, 1, 2.
1, 2.
What's the slope from E to H?
1, 2.
Okay, so that's the same. Let's do E to F. What's the slope from E to F?
4, 4, 3.
What's the slope from H to G?
4, 3.
Are the opposite sides the same slope?
Yes.
So is this parallel?
Yeah.
Yeah. Okay, so in the coordinate plane, we're just going to look at some of those slopes. You can also use the distance formula if you wanted to, but would that probably be a little bit harder than slope?
Yeah.
Yeah, let's just use slopes if we want me to use that. Okay, we can also use distance. All right, let's try this one here. 13, JKLM. J is at -2, -2. K is at -3, 3. L is at 1, 5. And M is at 2, 0. So I have J, K, L, M. And I'm going to determine this by finding the slopes. So take a couple seconds and find the slopes of all four of those lines on your own. Hannah or Audrey, which one of you got it here? I want the slope from K to L. Hannah or Audrey, what's the slope from K to L?
Same answer.
What? From K to L? Isn't it 2/4?
No, was it?
Which is 1/2? Shh, focus. What about from J to M? What's my slope? 2/4, which is also 1/2. Okay, now I'm going to do K to L. Or sorry, K to J. What's my slope from K to J? -5. Nice job. And the slope from L to M? It's also going to be -5. Are the slopes of the opposite lines the same? Is this parallelogram? Yeah, it's a parallelogram. Last one. Take a couple seconds, try 16 on your own. Again, we want to do it by recognizing these slopes. So don't worry about that. We want to do the...
Can you plot the points?
Yeah, points.
I can plot the points, yeah. -3, -2, 0, 2, 2, 2, and -1, -2.
Thank you.
So the hunting spot that I go to, it's like, well, so it's by Venice over here.
All right, take a couple seconds, work these out on your own. All right, I need to find the slope here. What's the slope from O to A? Jake O'Connor, O to A. From N to H. From N to O. Huh? And from H to A. So is this a parallelogram? Oh, jeez. Yes, it is a parallelogram. Nice shot.
High five, BJ.
Wait a second here. Wait a sec. It's coming. It's coming. It's coming.
Were you recording? Yes.
Yeah.
Recording.
Here's your assignment.